Assalamualaikum warahmatullahi wabarakatuh. Greetings to Madam Dr. Zalina binti Zainal Abidin. My name is Ayuddin bin Muhammad Rafi'i, and in this video, my group mate and I will talk about waste management in fusion and fission. So this is the member of this group presentation. The first one Aisa Amza bin Azman, and the second one is Iman Mukhlis bin Azrul Hanidi, and the last one is me myself, Ayuddin bin Muhammad Rafi'i. I think that's all for this now. And the next slide, Aisa Amza will talk about the introduction for this topic in this video.
So we start our presentation with introduction first. So what is waste management in fusion and fission? It is a process on how radioactive byproducts are handled after energy is generated in a power plant. Fission is a process of splitting atom like uranium that can create a lot of radioactive waste that can stay dangerous for 1,000 of years. In the other hand, fusion is a process of combining like atom like hydrogen that can create much less waste. Fusion is a promising future technology that is expected to generate far less and shorter-lived waste. The reason we chose this topic because nuclear energy is a key focus in modern physics and energy policy. With a concern of climate change, fusion is being explored as a cleaner alternative to fossil fuels. We conducted independent research using articles from Google and educational videos from YouTube. The challenges that we face is conflicting gathering of all information. The solution that we propose is to cross-check multiple times to make sure the facts. This is to make sure our information is accurate.
Hi, my name is Ayuddin Muhammad Rafi'i. So for now, I will talk about concept for waste management in fusion and fission. What is nuclear fission? Nuclear fission is a process where a heavy atomic nucleus splits into two smaller nuclei, releasing a large amount of energy and radioactive waste. For an example for nuclear fission is uranium-235. Next, what is nuclear fusion? Nuclear fusion involves combining two light nuclei to form a heavier nucleus, releasing energy with minimal long-term waste. For an example for nuclear fusion is isotopes of hydrogen like deuterium and tritium. What is the important for waste management in fusion and fission? Both are used to generate energy, but fission is widely used today, but produce long-lived radioactive waste, while fusion is still in development, but seen as a cleaner, safer energy source. Understanding their ways help ensure safe, sustainability energy use in the future. Next, factual details and example. Fission. Fission used in power plants today creates high-level waste that must be stored safely for thousands of years. For an example, is the Fukushima disaster in 2011. Next is fusion. Fusion is still in research, but it produces lower risk waste. A key project is ITER in France, which aims to make fusion power a reality. After that, application in daily life. Nuclear fission is already used in many countries to generate electricity. It provides a stable and reliable energy source, especially in countries like France and the United States. Besides that, radioactive materials from fission are also used in the medical field. For an example, in cancer treatment using radiotherapy. Fusion, although not yet commercially used, has huge potential. If fusion energy becomes successful, we could enjoy clean, safe, almost unlimited energy. This could replace fossil fuels and reduce air pollution, which would benefit our environment and health in the long term. For recent advancement and controversies, in terms of recent progress, a major breakthrough happened in 2022 at the National Ignition Facility in the United States, where scientists achieved a net energy gain from a fusion reaction, a historic moment for modern physics. Meanwhile, the ITER project in France is working toward building the first practical fusion reactor. However, there are still challenges. Fusion reactors are extremely expensive and complicated, and it may take years before we see them used on a large scale. On the other hand, fission is already in use but faces controversy due to its dangerous radioactive waste and accidents like Chernobyl and Fukushima, which raise public fears.
So now let's explore how self-development supports carriers in managing nuclear waste from fusion and fission energy systems. As you can see, these carriers play vital roles in ensuring the safe disposal and handling of radioactive waste. A mix of technical and regulatory skills are essential for ensuring safety and innovation in this field. With evolving waste treatment methods and international standards, professionals must keep learning and adapting. In conclusion, waste management in fusion and fission is essential for safe nuclear progress. With the right knowledge and continuous growth, we can ensure a clearer, safer future. That's all from us. Thank you.